On the morning of September 14th, 1942, a grey mist hung low over the waters of Kure Naval Arsenal, Japan's most prestigious shipyard. Commander Takeshi Yamamoto stood at the edge of Dock 7, watching as tugboats carefully maneuvered an unusual vessel into position. The submarine before him was not Japanese. It was American, captured 3 weeks earlier after running aground on a reef near the Solomon Islands. Its hull bore the designation USS Perch, and it represented something the Imperial Japanese Navy had desperately wanted for months: an intact enemy submarine to study, to dissect, to understand. Yamamoto believed this would be a straightforward exercise. Japanese submarines were among the finest in the world, he thought. They were longer, faster on the surface, and carried the devastating Type 95 torpedo, a weapon so advanced that nothing in the American arsenal could match it. This captured vessel would simply confirm what he already knew, that American engineering was adequate but unremarkable, practical but uninspired. He expected to spend perhaps 2 weeks cataloguing its systems before filing a report that would gather dust in some admiral's office. Before we dive into this story, make sure to subscribe to the channel and tell me in the comments where you're watching from. It really helps support the channel. What Commander Yamamoto could not have known that misty morning was that the next 60 days would fundamentally alter his understanding of industrial warfare. The submarine before him contained secrets that would keep him awake at night, not because of any single revolutionary technology, but because of what those technologies collectively revealed about the enemy Japan had chosen to challenge. By the time his team completed their examination, Yamamoto would understand why the conflict in the Pacific was already lost, even as Japanese forces continued to advance across the ocean. The examination team assembled that first morning consisted of 12 men, each selected for specific expertise. Lieutenant Commander Hiroshi Tanaka led the propulsion analysis group. He had spent 15 years studying diesel engines and electric motors, and he approached the American submarine with barely concealed skepticism. Chief Engineer Kenji Watanabe headed the hull and structural team, a meticulous man who measured everything twice and trusted nothing he had not personally verified. Lieutenant Saburo Ito commanded the electronics and communications group, while Ensign Yuki Nakamura, the youngest member at 23, was assigned to document everything with detailed drawings and photographs. Yamamoto gathered his team on the dock before they boarded. The American crew had been captured along with the vessel, and preliminary interrogations had revealed little of value. The submarine's captain, a man named Lieutenant Commander David Hurt, had been cooperative but vague, answering questions about his personal background while deflecting anything technical. This was expected. What mattered now was the submarine itself. They entered through the forward torpedo room hatch, descending a ladder into the dim interior. The first thing Yamamoto noticed was the smell, or rather, the relative lack of it. Japanese submarines were notorious for their poor ventilation, the air inside becoming nearly unbreathable after extended dives. This vessel smelled of oil and metal, certainly, but there was a freshness to it that surprised him. He filed this observation away and moved deeper into the boat. Tanaka went straight to the engine room, his team carrying notebooks and measuring instruments. Watanabe began his hull inspection from the inside, running his hands along the pressure hull plates, examining welds, testing fittings. Ito disappeared into the conning tower to study the radar and sonar equipment. Nakamura followed Yamamoto, camera ready, as the commander began a general survey of the vessel. The first report came from Tanaka 3 hours later. He appeared in the control room where Yamamoto was examining the diving controls, and his expression was troubled. "The engines," he said. They needed to discuss the engines immediately. They gathered in the crew's mess, the largest open space in the submarine. Tanaka spread his notes across the table, his hands not quite steady. The American submarine was powered by 4 diesel engines, he explained, each producing 1,600 horsepower. This was not remarkable in itself. What was remarkable was their construction. "Every component is standardized," Tanaka said. "Every bolt, every fitting, every gasket. I removed a fuel injector from engine number 1 and compared it to the corresponding part from engine number 3. They were identical, not similar, identical. I could swap them without any modification. Yamamoto frowned. This seemed like a minor observation. Of course, parts should be interchangeable. That was basic engineering. Tanaka shook his head. Commander, you do not understand. In our submarines, each engine is essentially hand-built. Parts from one engine cannot be used in another without extensive fitting and adjustment. Our machinists spend weeks ensuring each component matches its specific location. The Americans have achieved true interchangeability. Do you understand what this means for production? The implications began to dawn on Yamamoto. If parts were truly standardized, then assembly became dramatically faster. Workers did not need years of training to hand-fit components. Repairs in the field became simple matter of replacement rather than skilled fabrication. A submarine that lost an engine could receive parts from any warehouse, any other vessel, and have them installed by any competent mechanic. But it was Watanabe's report the following day that truly disturbed the team. The chief engineer had spent 16 hours examining the pressure hull, and he requested that everyone see something in the forward torpedo room. They followed him through the narrow passageways, squeezing past equipment and ducking through hatches until they reached the bow. Watanabe pointed to a section of hull plating. Here, he said. Look at this weld. Yamamoto leaned close. The weld was smooth and consistent, a neat bead of metal joining two plates. It looked like every other weld he had seen in his career. This weld was made by a machine, Watanabe said quietly. Not by a man, by a machine. The team stared at him. Automated welding existed certainly, but it was used only for simple, non-critical joints. The idea that Americans were using machines to weld submarine pressure hulls, components that had to withstand crushing depths, seemed impossible. Watanabe continued, I have examined over 300 welds in this vessel. Approximately 70% show the same characteristics: consistent speed, consistent penetration, consistent bead profile. No human welder, no matter how skilled, produces this level of uniformity. The Americans have automated their submarine construction. I have also measured the hull thickness. He added, it is uniform to within 1/10 of a millimeter across the entire vessel. Our submarines vary by as much as 2 millimeters in the same measurements. This precision is achieved only through machine tools that we do not possess. That evening, Yamamoto sat alone in his office, staring at the reports. The implications were becoming clearer with each passing hour. This was not merely a matter of clever engineering or innovative design. This was evidence of an entirely different approach to manufacturing, one that prioritized standardization, automation, and precision on a scale Japan could not match. He thought about what he knew of American industrial capacity. Before the conflict began, he had read intelligence reports about their automobile factories, their steel mills, their shipyards. The numbers had seemed abstract then, figures on paper that bore little relation to the reality of warfare. Now those numbers were taking on terrible significance. The third day brought Lieutenant Ito's report on the electronics systems, and it was perhaps the most troubling of all. Ito was a careful man, not prone to exaggeration, but his voice carried an edge of disbelief as he described what he had found. The radar system, he said, it is not merely functional, it is elegant. He led the team to the conning tower, where the radar equipment was installed. The American system used a type of vacuum tube that Ito had never seen before, smaller and more efficient than anything in the Japanese inventory. The assembly was modular, he explained, meaning that faulty components could be quickly identified and replaced. The entire unit was designed for ease of maintenance, with clear labels, accessible connections, and logical organization. But what truly amazed Ito was the manufacturing quality of the individual components. He held up a vacuum tube, turning it in the light. This tube, he said, is one of hundreds in this system. I have tested 37 of them. Their performance specifications vary by less than 2%. In our own equipment, variation of 10 to 15% is considered acceptable. This level of consistency is only possible through quality control processes that we have never implemented. Yamamoto took the tube and examined it. It was a small thing, perhaps the size of his thumb. Yet it represented something vast, a manufacturing system capable of producing millions of identical components, each one precisely matched to specifications, each one interchangeable with every other. He tried to imagine the factories required for such production, the machinery, the training, the organization. The scale was almost beyond comprehension. By the end of the first week, the team had developed a routine. Each morning they gathered to share findings from the previous day, then dispersed to continue their examination. Nakamura's drawings and photographs filled dozens of notebooks, creating a detailed record that would eventually be sent to Tokyo. But Yamamoto increasingly felt that the true significance of their work could not be captured in technical specifications alone. On the 8th day, they discovered the crew amenities, and this opened a new line of inquiry. The American submarine contained a small galley with an electric stove, a refrigeration unit, and storage for fresh food. There were bunks for every crew member, not the shared sleeping arrangements common on Japanese vessels. The boat even had a small shower facility. These features might have seemed like luxuries, evidence of American softness, but Yamamoto recognized them for what they were: investments in crew endurance. A sailor who ate hot meals, slept in his own bunk, and could maintain basic hygiene would remain effective longer than one who did not. The Americans were not coddling their crews. They were optimizing them, treating human beings as systems to be maintained just like engines and electronics. Tanaka made another discovery that week that illustrated the same principle. The American diesel engines were equipped with an array of monitoring instruments that far exceeded anything on Japanese submarines. Temperature gauges, pressure indicators, flow meters, and vibration sensors provided the engineering crew with constant information about engine performance. Problems could be identified early, before they became serious, allowing for preventive maintenance rather than emergency repairs. Our approach is to build robust engines and train crews to nurse them through problems, Tanaka observed. The American approach is to build engines that tell you when something is wrong so you can fix it before it fails. It is a different philosophy. It assumes you have the parts to make repairs and the time to install them. The second week brought examination of the torpedo systems, and here the team expected to find American inferiority. The Japanese Type 95 torpedo was the finest in the world, with its pure oxygen propulsion system that left no visible wake. American torpedoes used compressed air, producing a trail of bubbles that could reveal the weapon's path. In this area, surely, Japanese engineering would prove superior. The technical comparison bore this out. The American Mark 14 torpedo was in many respects a less sophisticated weapon than its Japanese counterpart. But as the team examined the torpedoes in detail, other factors emerged. The American weapon was simpler to maintain, its components were standardized. A torpedo that malfunctioned could be quickly repaired with readily available parts, and the submarine carried a supply of spare components that would have been unthinkable on a Japanese vessel. Yamamoto thought about what this meant in practice. A Japanese submarine on patrol might carry 12 torpedoes. If one malfunctioned, it was effectively lost until the submarine returned to port for professional repairs. An American submarine could potentially repair torpedoes at sea, maintaining its combat effectiveness throughout a patrol. The Japanese weapon was better in isolation, but the American system was better in aggregate. There was another factor that the team discussed late one evening, speaking quietly among themselves, as if reluctant to voice it. The American torpedoes showed evidence of recent improvements. The Mark 14 they were examining was not the same weapon the Americans had deployed at the start of the conflict. It had been modified, updated, refined. The Japanese Type 95, for all its excellence, had remained essentially unchanged since its introduction. The Americans were learning and adapting. They were improving their weapons based on combat experience and feeding those improvements back into production. In the third week, Lieutenant Ito made a discovery that he initially could not explain. The submarine's radio room contained a secondary communications system that did not match any equipment in the Japanese intelligence files. It took him 2 days to understand its purpose. It was designed for coordinating operations between multiple submarines. The implications were significant. Japanese submarines operated almost exclusively as individual vessels, sometimes receiving instructions from shore commands, but rarely communicating with each other at sea. This American equipment suggested a different doctrine, one in which submarines operated in groups, sharing information and coordinating their movements. It was a tactical approach that required reliable equipment, standardized procedures, and extensive training, the same combination of factors that characterized everything else in the vessel. On the 18th day, Yamamoto called his team together for a comprehensive review of their findings. They gathered in the American crew's mess, surrounded by the evidence of their work: notebooks, drawings, photographs, samples. Each man presented his conclusions, and as the hours passed, a picture emerged that none of them could have anticipated. The American submarine was not a superior design. In several respects, Japanese submarines were more capable. They were faster, longer-ranged, and carried better torpedoes. But the American vessel was something more dangerous than a good design. It was a manifestation of industrial power. Every system showed the same characteristics: standardization, precision, interchangeability, ease of manufacture, ease of maintenance. These were not features that would be noticed in a single engagement. They were features that would determine the outcome of a prolonged conflict. A navy that could build submarines quickly, repair them easily, and keep them operating at sea for extended periods would eventually overwhelm a navy that could not. Tanaka had calculated some numbers that he shared with the group. Based on the manufacturing characteristics they had observed, he estimated that the Americans could build this class of submarine in approximately 6 months. Japanese submarines of comparable size required 12 to 18 months. The Americans could also probably build them with fewer skilled workers, lower costs, and more consistent quality. These are not precise figures, Tanaka admitted, but the order of magnitude is correct. They can build 2 or 3 submarines in the time it takes us to build one. Watanabe added his own observation. The quality control they have achieved means fewer failures, he said. Our submarines spend significant time in repair facilities dealing with defects that should have been caught during construction. The Americans have pushed that quality control upstream into the manufacturing process. Their submarines leave the shipyard ready to operate. Yamamoto listened to his team and felt a cold certainty settling in his stomach. He thought about the reports he had read before the conflict began, the ones that described American industrial capacity in abstract terms: 32 million tons of steel production annually, 4 million automobiles, shipyards on both coasts capable of continuous production. He had known these numbers. He had not understood them. Now, sitting in the crew's mess of an American submarine, he understood. This vessel was not just a machine of war. It was a message. It said, "We can build these by the dozen, by the 100, and we can keep building them faster than you can sink them." It said, "Your skill, your courage, your superior tactics, none of it will matter in the end because we will bury you in production." In the 4th week, Yamamoto began writing his report. He knew it would be read by senior officers who might not appreciate its conclusions, men who believed in the fighting spirit of Japanese forces and the destiny of the nation. He had to be careful, presenting his findings in technical terms while making the larger implications clear to anyone willing to see them. He wrote about the engines and their standardized parts. He wrote about the automated welding and precision hull construction. He wrote about the electronic systems and their consistent manufacturing quality. He wrote about the crew amenities and their effect on endurance. He wrote about the maintenance philosophy that assumed ready access to replacement parts. He wrote about the communications equipment designed for coordinated operations. And then he wrote the section that he knew would be most difficult to accept. The American approach to submarine construction, he explained, reflected a broader industrial philosophy that prioritized quantity and consistency over individual excellence. This philosophy had certain disadvantages in terms of performance characteristics, but it had overwhelming advantages in terms of production capacity and operational sustainability. He included Tanaka's estimates about construction time. He included Watanabe's analysis of quality control. He included Ito's assessment of the maintenance implications. And then he wrote the conclusion that had been forming in his mind since the 2nd day of the examination. The vessel we have examined represents not just American submarine technology, but American industrial capability. Our analysis indicates that this capability is significantly greater than previous estimates suggested. If the Americans are able to apply this capability to submarine production, they will be able to sustain losses and maintain operational tempo at a level we cannot match. He paused before writing the next sentence, knowing it might end his career, but he was a naval officer, and his duty was to tell the truth as he understood it. It is the recommendation of this examination team that our strategic assessments be revised to account for these findings. The enemy's industrial capacity may be the decisive factor in the current conflict. On the 35th day, something unexpected happened. Yamamoto received word that a group of senior officers would visit the submarine to receive a briefing on the examination findings. This was unusual. Technical reports normally circulated through channels without such personal attention. Someone in the Naval Command had recognized the significance of his preliminary communications. The delegation arrived on a grey morning similar to the day the submarine had been brought in. There were 5 admirals and several captains, accompanied by staff officers and aides. Yamamoto met them at Dock 7 and led them aboard the vessel, following the same path he had taken on that first day. He showed them the engines and explained the standardization of parts. He showed them the hull and explained the precision of the machine welding. He showed them the electronics and explained the consistency of the components. He showed them everything his team had documented over the past 5 weeks, presenting the evidence clearly and letting them draw their own conclusions. Most of the officers listened politely, asked a few questions, and maintained carefully neutral expressions. But Yamamoto noticed that one of them, a rear admiral named Kato, became increasingly quiet as the tour progressed. Kato was an engineer by training, one of the few senior officers who truly understood manufacturing processes. His silence was more eloquent than any comment. After the tour, the delegation gathered in a conference room at the arsenal for the formal briefing. Yamamoto presented his findings systematically, covering each area that his team had examined. He used the drawings and photographs that Nakamura had prepared, showing specific examples to illustrate his points. He kept his tone neutral, factual, professional. When he finished, there was a long silence. Then one of the senior admirals spoke. "Commander," he said, "you seem to be suggesting that American submarines are superior to our own." Yamamoto chose his words carefully. "No, Admiral. In several important respects, our submarines are more capable. What I am suggesting is that the American approach to construction allows them to build submarines faster, in greater numbers, and with more consistent quality. Over time, these factors may prove more significant than individual vessel performance." Another officer spoke up. "Our crews are better trained," he said. "Our tactics are superior. These factors also matter." "They do, sir," Yamamoto agreed. "But our examination indicates that the Americans are designing their equipment to be operated effectively by average crews. They are not depending on exceptional performance. They are building systems that work reliably under normal conditions." The admiral who had first spoken frowned. "What you are describing sounds like a factory, not a navy." Yamamoto nodded. "That is precisely the point, Admiral. The Americans appear to be applying factory methods to naval warfare. They are treating submarines as products to be manufactured in quantity, rather than as individual craft to be hand-built by skilled workers." The room was silent again. Yamamoto could see that some of the officers understood what he was saying, and understood as well what it implied for the conflict. Others seemed to regard his analysis as somehow disloyal, as if recognizing enemy strengths was the same as accepting defeat. Admiral Kato finally spoke. He had been silent throughout the briefing, studying the drawings and photographs that had been distributed. "Commander Yamamoto," he said, "your report will include recommendations?" "Yes, sir. And these recommendations will address the implications for our own production methods." Yamamoto hesitated. He had thought carefully about this question, knowing that it would be asked. The honest answer was that Japan could not replicate what the Americans were doing. The manufacturing infrastructure did not exist. The raw materials were not available. The industrial philosophy was fundamentally different, but saying this directly would accomplish nothing except to end his career. "The report will suggest areas where American methods might be adapted to our circumstances," he said carefully. "It will also note the limitations on such adaptation." Kato nodded slowly. "I see." The delegation departed that afternoon. Yamamoto stood at the dock and watched them leave, knowing that his report would be filed and probably forgotten. The Navy was not going to change its construction methods based on one examination of one submarine. There was too much institutional momentum, too many established relationships with shipyards, too much pride in traditional craftsmanship. In the days that followed, Yamamoto completed his report and submitted it through channels. He included all the technical findings, all the calculations, all the conclusions. He also included a final section that he knew would never be acted upon, but which he felt compelled to write. The examination of this American submarine has revealed fundamental differences in industrial philosophy between our Navy and the enemy's, he wrote. These differences favor the enemy in a prolonged conflict. While individual Japanese submarines may be superior in specific characteristics, the American approach enables production at a scale and pace that we cannot match. Our strategic planning has assumed that the enemy can be defeated before his industrial capacity becomes decisive. The findings of this examination suggest that this assumption may be optimistic. The enemy's industrial philosophy is already embedded in his current production. It is not a future capability that might be developed. It is a present reality that is already being deployed. He signed the report and sent it up the chain of command. Then he returned to the submarine for one final visit. The vessel sat quietly in Dock 7, just as it had for the past 6 weeks. Yamamoto walked through its compartment slowly, looking at the equipment his team had studied so carefully. He thought about the men who had built this submarine, workers in some American shipyard, probably civilians who had never been to sea. They had used machines and standardized processes to create this vessel, likely one of dozens under construction at the same time. They had not known or cared about the specific boat they were building. They had simply followed procedures and installed components that had been manufactured somewhere else by other workers following other procedures. And that was the point, he realized. That was exactly the point. The Americans did not need exceptional workers to build submarines. They needed average workers following good processes. They did not need master craftsmen to maintain these vessels. They needed competent mechanics with access to spare parts. They had designed their entire system to work reliably without depending on individual excellence. Japan's approach was the opposite. Japan depended on excellence. Japanese submarines were built by highly skilled workers who hand-fitted components and adjusted systems to achieve optimum performance. Japanese crews were extensively trained to operate equipment that required expert handling. Japanese tactics assumed superior skill and fighting spirit. The entire Japanese military philosophy was built on the idea that quality would defeat quantity. But what if it did not? What if the quantity became so overwhelming that quality ceased to matter? What if the Americans simply built so many submarines, so many aircraft, so many ships, that Japanese forces were ground down by sheer numbers? Yamamoto stood in the control room, his hand resting on the periscope housing. This is what defeat looks like, he thought. Not a lost battle. Not a sunken ship. This ordinary, unexceptional submarine built by ordinary, unexceptional workers. This product of a system designed to produce more than we can destroy. He left the submarine and walked back to his office. The mist had returned, grey and cold, obscuring the other vessels in the harbor. Somewhere out there he knew American shipyards were working around the clock, building more submarines just like this one. And Japanese shipyards were doing their best, building their excellent submarines one at a time with their skilled workers and their traditional methods. It would not be enough. He knew that now with absolute certainty. It would not be enough. 3 months later, Yamamoto was transferred to a position at Naval headquarters, a promotion that he suspected was actually a way to bury his report and its uncomfortable conclusions. He spent the remainder of the conflict reviewing intelligence assessments and writing analyses that were read by few and acted upon by none. The Americans did exactly what his examination had predicted. They built submarines by the hundred. They built aircraft carriers, destroyers, landing craft, transport ships. They built aircraft in numbers that defied comprehension, tens of thousands of fighters and bombers rolling off assembly lines that ran day and night. They buried Japanese forces under a mountain of production that no amount of skill or courage could overcome. After the conflict ended, Yamamoto was interviewed by American technical intelligence officers who were interested in Japanese submarine capabilities. He answered their questions carefully and completely, feeling a strange relief in finally being able to speak openly about what he had observed. When they asked about the examination of the captured American submarine, he told them everything. One of the American officers, a lieutenant commander who had served on submarines himself, listened to Yamamoto's account with growing interest. When Yamamoto finished, the American shook his head slowly. "You know," he said, "we knew our boats weren't as good as yours in a lot of ways. Your torpedoes were better. Your crews were better trained. Your submarines were faster. We had a lot of problems with our equipment, especially early in the war. A lot of failures, a lot of missed opportunities. But we could build them," he continued. "God, could we build them. By 44, we were commissioning a new fleet submarine every week, and we could keep them at sea for 2 months at a time because they were easy to maintain and we had parts for everything. Your submarines were works of art. Ours were products, and in the end, products won." Yamamoto nodded. He had known this for 3 years, since the day he first examined those standardized engine parts. The American officer was simply confirming what the evidence had already made clear. In the years that followed, Yamamoto often thought about the lessons of that examination. Japan rebuilt its economy, using many of the manufacturing principles he had observed in the American submarine. Standardization, quality control, precision engineering, continuous improvement. Japanese products became known worldwide for their reliability and consistency, the same characteristics that had once seemed so threatening when he found them in an enemy vessel. He never forgot the feeling of standing in that American submarine and realizing what it meant. The feeling of seeing ordinary components assembled with extraordinary precision. The feeling of understanding that industrial capacity was not just a factor in warfare, but perhaps the decisive factor. The feeling of knowing that his country had challenged a productive power that it could not hope to match. It was, he would later say, the most important examination of his career. Not because of what it revealed about American technology, but because of what it revealed about American capability. The submarine itself was almost irrelevant. What mattered was what it represented. A system, a philosophy, an approach to manufacturing that could produce weapons faster than they could be destroyed. That was the real lesson of the captured submarine. That was what kept him awake at night during the conflict and what stayed with him for the rest of his life. The understanding that sometimes a nation's fate is determined not on the battlefield, but in the factory. And the recognition that he had seen that fate clearly, documented it precisely, and been unable to change it at all. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II, and check out the video on screen for another incredible tale from history. Until next time.